Hey guys, so today we're going to go over something called correlation versus causation. These are two different things, but they mean somewhat similar. So let's go over this. Correlation, think of that almost like two different things that have a relationship. They're somewhat connected to each other. Whereas causation is when those two different things has almost a cause and effect. So one leads into the other. They're directly connected. Think two different sports teams have a relationship, but generally one doesn't affect the other. Unless here, you know, if two hockey teams are playing and, if one needs to get into the playoffs by another team losing, that's a cause and effect. So here, it's just any vague relationship. Here, they affect each other. With correlation, it's a description. So you're going to say there's a strong or a weak or a strong negative or a strong positive correlation. Generally, we do that with a scatter plot. We have a bunch of little data here. And if we were to draw a line, generally that's going to be a negative. And because everything is kind of close to that line I just drew, it's strong. And we'll go over that a little bit more in just a second. So, one measure of the strength and direction of a linear association, so this information here, is a correlation coefficient, which is sometimes shown as R. Now, quick note, you're not going to have to solve R. Usually it's computer systems and programs that figure that number out for you. But what we just need to do is understand what it means. So the value of R, the correlation coefficient, can range from -1 to 1. And this value of R, like I said, is usually calculated with some piece of technology. If it is a positive number, it is going to have a positive correlation. And if it is a negative number, it's going to have a negative correlation, meaning negative. So this is going down, so it's a negative, right? Whereas this is going up, so that's positive. Now, in terms of how I said this is a strong correlation versus a weak, is what we're going to use this number for. So the stronger the correlation, the closer our R will be to either 1 or -1. And the weaker the correlation, the closer it'll be in the middle at 0. So to kind of visualize this a little bit, think of it as a number line. So I have -1 on this side, I have 0 in the middle, and I have 1. So this side in the negatives is a negative correlation. On this side, it's positive. If it's closer to 1, it's strong. If it's closer to 0, it's weak. Same thing on this side, just flipped. So if it's closer to 0, it's weak. But if it's closer to -1, it's a strong. So that's a good visualization to understand this concept. To show a few examples. So I forgot to do this. So this is giving us a bunch of information here. And if you were to run this through a computer program, these are the coefficients that we would be getting. So it would look like this. It would look like -0.991, -0.547, So we have 3 negatives because they are going down, down, and just slightly down, and we have 2 positives here. The closer the points are to the line, so notice how all of these guys right here are really close to this line. That's why it's very, very close to -1. But if you notice here, there's points all over the place. They're not as close to this line that's right here. That's why it's a little bit closer to 0. Now this one, it's all over the place. It's all over here, meaning it's really close to 0. This guy right here, they're still close, but not as close as this guy here, which is why this one is a little bit closer to +1 versus this one here. So the closer to R is to 0, the weaker the relationship. And then if you have two numbers that are absolute values, if you don't know what an absolute value is, it's usually like this. So like 0.5 would mean 0.5, and it would mean negative 0.5. It just means how far away is something to 0. It's that far away. So if you get something where it's positive and the negative version, they are equal strength, but they're in opposite directions. Example 2 here gives us a bunch of information about the temperature of a day versus how many like ice cream cones are sold like on an ice cream truck. And if we kind of look, when it's really hot, there's a lot of ice cream sold. When it's a little bit colder out, there's less, right? So it gives us that the R, the coefficient, is 0.984, and that's pretty close to 1. So that would make it a strong positive relationship. And just to finish this up, because I'm just about done, this one gives us a bunch of information here. It even gives us the R value, which is negative 0.907. That's pretty close to -1, meaning strong negative. And you can kind of see if we draw a line here, everything's pretty close to this line here. All right, one more. And kind of this one gets a little bit into the causation part of this. So this one is talking about a survey found that students who spend more time doing algebra homework also spent more time doing bio homework. So it wants you to identify the variables, and it wants you to identify the correlation, and then it's talking about discussing whether the correlation is a result of causation. So there is a relationship, but we need to see if they are directly connected or if they're just two variables. So the variables are going to be the time spent on algebra and the time spent on bio. Those are our two. Now, it says that if somebody spends more time doing homework on algebra, they are also doing more, spending more time in bio, right? So there's a positive correlation. As one variable increases, the other one also increases. If I'm on a graph, it would look like this. Now, causation. Generally, if people are spending more time on homework in one class, it might be because they're a good student and they have balanced their time. So if they do more homework in one class, they might do more homework in another class as well. It's not to say that those two things are directly tied into each other. It's just the idea that it's a good student doing their work. So is there causation? Not really. Those are two separate classes. There's no like deal being made or anything like that with the two classes. So one variable does not cause the other. It's just what those students are doing. So that's all I got for you today, guys. Thanks.